If you've ever wondered whether or not you can run CATIA on an Apple device with M1 and M2 series CPUs, I'm here today to answer this question. Stay tuned. Hello everyone. If you are new here, my name is Hamid. I'm a research engineer based in Montreal, Canada. And in this video, I will present my experience with running CATIA V5 on a Mac device with Apple Silicon CPUs, specifically the M1 Mac Mini and M1 Max MacBook Pro. I previously shared my satisfactory test results of running other engineering software such as SolidWorks, Abacus, and NX on Mac devices, among which the performance I observed with NX and Abacus was nothing short of perfect. Now, after almost 1 year, I finally got the chance to test CATIA V5 as the most requested software in the comment section. I first installed CATIA V5 on a 16-inch MacBook Pro with an M1 Max CPU and 64GB of RAM. The virtual machine had the latest version of Windows 11 ARM from Parallels with 16GB of RAM assigned. The installation process went smoothly and without any issues. The version of CATIA that I was able to use for testing was the V5 2021 version, being the only version I had access to a license for. But what about any performance benchmark? Even though we all know that these benchmark numbers can be quite useless when it comes to evaluating the true performance of a software like CATIA. Well, there is no straightforward way to benchmark the performance of CATIA, at least nothing similar to SolidWorks that I'm aware of. However, this doesn't mean that I left it with no usable feedback. Thanks to some good friends who have been using CATIA for years, I was able to at least verify what kind of performance you can expect from running CATIA on Apple Macs with M-series CPUs. Turned out, unlike SolidWorks, CATIA's graphic engine has some compatibility issues with the GPU driver provided for the virtual machine. As a result, smaller models like single parts or basic assemblies still work well, but the user experience won't be as smooth as soon as you start working with relatively large models. This was a surprise since I remember the very good graphical performance from my tests on Abacus, which uses a graphic engine quite similar to CATIA. After tweaking some settings, I finally started to observe smooth performance on single parts and smaller assemblies. The issue was found to be mostly with rendering edge lines, which I succeeded to address by defining a customized view for the render style. After deactivating the outline render in the customized view and lowering the details level in the graphic performance setting, the performance was quite acceptable even for a large assembly like this jet turbine with very minimum lags. I was happy to have a workable performance of CATIA V5 on the 16-inch MacBook Pro. Also, by activating the cache management under the infrastructure menu, the performance started getting even better. Opening large models and navigations, loading time, and responsiveness of the computer during edits all went kind of smoothly for ordinary jobs. Most importantly, in a consistent way and without showing any sign of stress on the hardware, which is a big advantage for a laptop. Make sure you watch till the end of the video to hear about another big advantage of these MacBooks in running Windows apps. Next, I installed CATIA V5 on a 2021 Mac Mini with the first gen M1 CPU. The installation process was the same as the MacBook Pro, and once again the performance was satisfactory. This was surprising because the M1 CPU on the Mac Mini is a lower end chip compared to the M1 Max CPU of the MacBook Pro, proving one more time that for most tasks, modern integrated GPUs can be quite effective. This is quite interesting considering how good of a value Mac Mini is as a desktop replacement for many workflows. Despite my relatively smooth experience with CATIA V5, there are still some limitations to keep in mind. For example, compared to desktop workstations with modern GPUs, you can expect slower 3D rendering and less responsive navigation as the size of the model gets larger or when performing complex operations. Although unlike many x86 Windows laptops, these MacBooks do have sufficient cooling systems to handle the heat generated by running demanding software, it definitely requires sacrificing some graphics quality or functionality to achieve better performance, which may be important for some in terms of overall user experience. Again, this virtualization is not going to be a workstation performance for top-level professional work in the industry, but quite acceptable for smaller jobs, casual users, and students. To stretch the test even further, I tried to find pieces of evidence to answer the frequently asked question about which version of Parallels you should choose. There are currently two options to get your license for Parallels: a standard one-time fee license and a subscription-based license, with the standard license being limited to 4 cores of CPU and 8 GB of RAM. Of course, it is a question only for people who have Mac devices with upgraded RAM and CPU. So, I limited the CPU and RAM of the virtual machine to the maximum that the standard version of Parallels allows. To my surprise, on this CATIA 2021 version that I tested, the performance was still good with no noticeable difference in a major part of a daily workflow for typical projects that are expected to be done by a laptop. So now that the Parallels for Apple Silicon is mature enough, I suggest only getting the subscription-based license if you need other software that can benefit from extra RAM and CPU cores of the virtual machine. Back to the performance. Of course, there are some limitations to consider when using virtualization software like Parallels. But in its latest version, Parallels 18, they have made some significant improvements in terms of performance and compatibility with the latest version of Mac OS as well as the new CPU architecture of Apple Silicon. As a result, the virtual machine can take full advantage of the latest hardware features to deliver the best performance possible. On top of this, one of the advantages of using a virtual machine is the ability to easily switch between different operating systems, which can be very useful for those who work with multiple platforms or need to test their applications on different operating systems. With such improvements, the gap between the native and virtualized performance continues to shrink, making it a viable option for many users. Besides, one of the great things about using a Mac for engineering work is the amazing battery life you can get. Even for running heavy software like CATIA through virtualization, you can expect your MacBook to last much longer than most Windows laptops. The 16-inch MacBook Pro was able to stay up and running for 6 to 8 hours on CATIA, which is quite extraordinary compared to standard Windows laptops. This is partly due to the efficient design of macOS, but also because the M1 chip is incredibly power efficient. And considering that the daily workflow of most of us includes lots of office tasks, emails, internet browsing, and so on, decent battery life is always a huge advantage. Finally, I want to point out the amazing job Microsoft is doing with the improvements on the x86 emulator in Windows 11R. This emulator allows you to run Windows apps designed for x86 processors on ARM-based devices like the M1 chip with very little performance loss. And while it may not perform as well as running the app natively on an x86 processor, it's still a considerable option for many people, especially casual users and students. And that was it for today. I hope you liked this video. Check out my other videos about Mac devices for engineering from these links. Thank you for watching. This is Hamid DLL, and I will catch you in the next video.